Hey everyone, so here is the second video of today's block day. If you are watching this as your first video, you probably clicked on the wrong link. You should watch the rectangle video first, and then the video on rhombus, or rhombi, is the plural. So we're going to get started with the definitions again. So back on the front page, a rhombus is still a parallelogram, but it's got some extra special qualities. Let's see, can we go over here? Okay, cool. I didn't know what it was going to look like. All right, a rhombus is a parallelogram, but this time it has all congruent sides. That's its special little quality. Kind of like how the rectangle has all right angles and the diagonals are congruent, the rhombus has all congruent sides. And it has a special little quality with its diagonals too, which we'll get to. The opposite angles are still congruent because it's a parallelogram. The opposite sides are still congruent and parallel, so that stuff is just parallelogram stuff. That's true for rectangles, rhombus, square, and just general parallelograms, so that's nothing new. The extra special thing as well is that the diagonals not only bisect each other, but they are also perpendicular. If you forgot, perpendicular means that they cross at 90 degrees. So it kind of looks like a T when you see it. Cross at 90 degrees, so it kind of looks like this. That would be a right angle. So the diagonals are going to cross at a perfect 90-degree angle. Obviously, it'd be 90 all the way around because it's perpendicular. And then the last little tidbit is that the consecutive angles are supplementary. Don't forget that supplementary means they add up to 180. Oops, apparently I can't spell add. That was embarrassing. Add to 180. Okay, and again, that's something we already knew. It's nothing new or exciting because we already knew that about parallelograms. So let's get our picture all sketched up and symboled and all that wonderful stuff. So it is a parallelogram with all congruent sides, which means all four of these get the same tick mark. It's kind of like a square that's been like squished on its side. Some of you guys learned it as that. By the way, feel free if you get done to color in the lovely shapes and pictures and letters, make it a little more colorful. Not before you get stuff done, but after would be fabulous. The opposite angles are congruent. That means this and this are congruent. And doing double arches because they are not all congruent angles. It's not like a rectangle where they're all right angles. There are two sets of opposite angles. The opposite sides are congruent and they are parallel. So let's put our arrows. And just like the rectangle, we need two sets of parallel lines because you can't have four parallel lines meeting each other. That kind of defeats the purpose. And then we need to draw our diagonals in. This time the diagonals are not congruent. It's pretty easy to tell that this one is longer than this one. Okay, it's pretty obvious that they're not like the rectangle. However, they do get their own little special property in that they cross at, oops, apparently we're doing lines now, at 90 degrees. That means that this is a right triangle, this is a right triangle, this is a right triangle, and this is a right triangle. In fact, they are all congruent because not only do the diagonals bisect, or not only are they perpendicular, they cut each other in half just like we're used to. So that means those lines are equal and these lines are equal. Now again, these four lines are not congruent, but they make four congruent triangles. So this little guy is the same as this one, is the same as this one, and the same as this one. They're all just kind of reflected differently, but they are the same triangle, I believe. I hope I'm saying that right. If not, that's kind of embarrassing. Yeah, I'm right. This is what happens when you do videos at night. You start to forget the stuff you learned in college. All right. Make sure you have that copied. Hopefully that gave you enough time to get all those words down. Moving along to the examples on the back side. There wasn't really much on the front for the rhombus. So scroll on down. We already filled in that top part. Scroll on down to the bottom to the rhombus section. So we're looking at AE first of all. That's part of our diagonal. There's that guy. Okay, so if AE is 8, I'm looking for AC. Okay, well this is actually pretty basic from the parallelogram section. we know that parallelograms have diagonals that bisect each other. Remember, bisect means to cut in half. If you have two halves, the halves must be equal. That's kind of the definition of half. It's cut into two equal groups. So if this is 8, then so is this. If I want the entire distance, I just have to do 8 times 2, or 8 plus 8. Either way, it's 16. So just a nice little easy problem to ease us into it. Next one, it says find the measure of angle CEB. Well, CEB is right here, and it's where two of the diagonals cross. Now, remember what we said about the diagonals. They bisect each other, and they are what? Take a look at your notes if you don't remember. Flip to the front. They are perpendicular. What does perpendicular mean? They cross at 90 degrees, or at right angles, which means all of these little cross sections are 90 degrees, which means that this definitely has to be 90 degrees. We don't even have to do any extra math for it. It's just part of the rhombus properties. Okay, next one, angle CBD. Let's get rid of some of this stuff on here. I'm going to erase some of our previous stuff. All right, angle CBD. So CBD is this angle, this little one right there, is 58 degrees. So let's label that. And I'm trying to find ACB, which is this guy. I'm just going to use a double arch there so I know it's different. Okay, so look at those two angles. What shape do they share? Obviously, they're still in the rhombus, but what specifically do they share? They're both a part of this triangle. Okay, now what do we know about triangles? And what do we know about all of their angles? They have to add up to 180 degrees. Well, I only know one right now, but do I know what this one is? Yeah, I should. I just figured it out over here. And even if I didn't, I should know that the diagonals of a rhombus cross at 90 degrees, which means that's also a 90. So all three of these have to add up to 180, which means, I'm not going to do that. I'm going to add up the two angles that I currently have. I've got 58 degrees and 90 degrees. That means together I have a total of 148 degrees already accounted for. I need them to add up to 180. So let's subtract out the group that we already have. That means we have 32 degrees remaining for angle ACB, which would be our answer. Okay, again, those three have to add up to 180. Because these diagonals cross and are perpendicular, they have to cross at 90 degrees. That's how I know what that is. Last problem, throwing a little bit more algebra in here. Let's get rid of some of this stuff so we're not confused by all the numbers. We've got that AD, which is a segment here. It's a side. So we're not going to be using 180 degrees. Do not use it on a side. That is 2x plus 4. And CD is 4x minus 4. Find x. Well, what do we know about the sides of a rhombus? Look back on the front. What did we just talk about? All of the sides are congruent. That's one of the new special things, and I forgot to do that with this section. These are the two special things with the rhombus. All the sides are congruent and the diagonals are perpendicular. That's the thing that's different than the regular parallelogram. So, oops, scroll back down. If all the sides are congruent, that means that all these segments are equal. If two things are congruent, I can set them equal to each other. AD is equal to CD because they're both sides of the rhombus, which means AD, which is 2x plus 4, and CD, which is 4x minus 4, must be equal to each other. From there, it's just our basic algebra. Okay, I'm going to move the 2x over here. Some of you have forgotten your algebra, so it's a good thing to watch this section too. Got to get x by itself, so let's move the 4 back over here. So I have 2x equals 8. Divide by 2 to get x by itself, and I get that x is 4. Now I do want to make sure that this is correct, so do extra 30 seconds, plug in the 4. 4 times 2 is 8. 8 plus 4 is 12, so I've got that AD is 12 units long. If I plug in 4 over here, 4 times 4 is 16. 16 minus 4 is also 12. They should equal the same number, so I'm good. I know I did the right thing here. Okay? Feel free to rewind or ask questions. This one's a little smaller section because we've been reviewing some of this stuff. So feel free to go get started on the rhombus section. Make sure to get it checked by a teacher when you are done. You should get rectangles checked before you move on to this one if you haven't already.